So as we discussed for the P1 session as well, that the mark scheme has different abbreviations. Was there anyone here who was not present in the P1 session and is only present here for the first time? Then we can also go over the mark scheme abbreviations once again. Was there anyone here? In that case, let's just start with the S1 part of the syllabus. So we're back to MF19, and the MF19 has formulas for this probability and statistics. So basically P5, and it also has for S2. So that is, I think P4. I think if I'm not wrong. So this is P5 for us. Um, these formulas are needed for us, as we have seen in the first couple of chapters. These work with the raw data values and the table values. So there is that. This is needed as well. This is from the binomial chapter. This is from the geometric distribution chapter, and these are from the SD. There, as you can tell, there's a lot of formulas that are not present here. So it's not like we can only rely on the MF19 for our preparation in the syllabus. With that being said, anything below this are all S2, and we don't have to look at those. Okay, so these are the only parts that we need from the syllabus for S1. So we'll just start off with that. There's this table as well. But I would highly recommend that, as well as using this table, you also know how to use the calculator for finding these values. So if you're using, once again, if you're using the same calculator as me, I'll just tell you what calculator I use, FX991 ES plus. So in my calculator, what I have to do is first go to mode setup and then press on 3. So that is stat. And then I just press on again. So, or just AC, let's just say AC. So I press AC to clear everything in front of you. Okay. On the top left corner, you're supposed to see a new sign pop up that says stat. Okay. So after this, you press on shift and 1. Yeah. Shift plus 1. So you should get something, a menu that says type, data, sum, var, distribution, and then min max. So we want the number 5 there. Okay, that will distribute. Distr. That's exactly what the calculator says. Is anyone else using the same calculator? Can you please give a thumbs up if you're using the same calculator, or if you've come up till this point? Okay, thank you. So I hope it makes sense. If you're using the same calculator but you still can't find this, please let me know and I'll try to help you. I'll just go over all of this once again. So we go to mode setup, that is right beside the on button, and we click on 3 that says stat. So after we do that, we clear our screen with AC. Menu is supposed to show up, but we don't use that. We just clear our screen, and then we see stat pop up on the top left corner, and then we press on shift plus 1. So shift plus 1 should give us this distribution option for number 5. So we click on that. We click on number 5, and then we should get something like this. 1P with a open bracket, Q, 3 says R. Okay? So this is basically what you're gonna get if you ever plug in this. So let's just to verify, press on number 1, and then you give P of, let's say, mm, 0.11. Okay, let's just get 0.11 and see what it gives us. So my calculator gives me 0.54379. And if you come down to this table for 0.1, so 0.11, I'm going to get this, which is the same value. Okay, so instead of wasting your time in the graph paper or this table, you can easily just use the calculator. The easiest way to remember this or to learn this is just type in your calculator model in YouTube and then you search on how to do normal distribution using this calculator. That's all you have to do, okay? So just search this, normal distribution. With this is your calculator's name. This is your calculator. Okay, so you should be able to get this entire method, and then you can also use the shortcut. This is not needed for us. It's a S2. This is also S2. And yeah, we don't have anything else. So the S1 has very little use in MF19, and you should already know all of these formulas before you show up in the exam. So as in, wait, all of no, this is P1. Yeah, all of these formulas you should be very familiar with before you show up in the exam, because these are not even that complex. These are the basic formulas that we start off with in the beginning of each chapter. So yeah, with that being said, let's start off with the question paper. We'll be doing the same thing. We'll be doing paper 5-2 of the last year. So you'll be sitting for MJ 2652, if I'm not wrong. Thank you so much for joining, Liz. I hope I'll be recording this, so I'll hope to provide this to you, and you can listen to this later, or you can watch this later for your help. Okay. Thank you so much for being so interactive. Bye bye. So let's start off with the paper. The first question says, so this paper is quite small, I think, since it's just 50 marks. Yeah, it's just 50 marks. So let's just go over the instructions real quick. There isn't a lot of things newly written here. It's the exact same thing. We have to use 3 significant figures wherever needed, and we have to use 1 decimal place for angles, even though angles don't exist inside a 6-1. So there's that. At times the question will tell you how much accuracy is needed. So they might even tell you to write the answer in 5 significant figures. So we have to be ready for that, and we have to apply it accordingly. With that being said, let's just start the paper. There's nothing much to discuss here. The first question says, Rachel has 3 coins. The first coin is biased, so that the probability of obtaining a head when it is thrown is 1/3. So a biased coin is something you're going to see very often. It's basically when it's not equal to the normal cases. So we know that a coin has 2 sides, heads and tails, and each of them should have the probability of half. But in a biased coin, that changes, and a head is 1/3. So H becomes 1/3, and tails becomes 2/3. Please read the question with me, since statistics is a very memorized type of paper, as in we memorize the formulas when we use those, and it requires very little thinking. So I would highly recommend that all of us, and since our class size is not as large as P1, I'd highly recommend that we all solve the paper together, and then you tell me wherever you feel stuck or your answer is not matching with mine. Okay. I think we have just 6 or 7 students in this class, so let's try to be as interactive as possible. Okay. Do any of you require time to bring your papers or anything, or can we all solve the paper together? Can you please confirm if you can solve the paper with me? Okay, thank you so much. So let's try solving the paper together, and we'll see where we get to. Okay. After I solve each question, I want you to first give me the answer that you got, and if it doesn't match, we can discuss about why it did not match. Okay. So let's go back to the question. Rachel has 3 coins. The first coin is biased, so that the probability of obtaining a head when it is thrown is 1/3, as we discussed. That means the tails should be 2/3. The second coin is biased, so that the probability of obtaining a head, so there's separate probabilities for each coin. This is C1. For C2, it's going to be, second coin is biased, so the probability of obtaining a head is 1/4. That means tails should be 3/4. The third coin is fair. So for C3, H is half and tails is also half. Let's just bring this to the actual paper. Okay. So Rachel throws the 3 coins at the same time. The random variable x is the number of tails that she obtains. Draw up the probability distribution table for x. How about I give you guys 3 minutes. You try to get to a point. I think it might take a bit more time. You take up to 5 minutes, and then you write the answer in the chat box, and then I start solving it for everyone. So it's fine even if you don't get the answer. I'm still going to solve it regardless. But let's try solving it together, okay? Can I give thumbs up if you understand? I want you guys to first attempt solving this, and then if you struggle, you let me know, okay? You guys keep on solving. I'll also start solving it. If any of you struggle at any point, please let me know, okay? So the question asks from us that the random variable x is the number of tails that she obtains. So we know that a probability distribution table looks something like this, where x denotes the number of times something happens, and then p denotes the probability of that happening. So in this case, since there are 3 coins and she throws all of them together, the number of tails can be 0, 1, 2, 3. Nothing more, nothing less. Cool? So for 0, we'd have to get heads for all 3 of the scenarios, right? So for p of 0, we get heads, heads, and heads. So that is 1 over 3 into 1 over 4 into half. As simple as that. And that should be 1 over 24 if I'm not wrong. So this is 1 over 24 for odd all heads. For one tail, it could be one of 3 scenarios. So p of 1. This is basically saying that either she gets tails, heads, heads, or she gets heads, tail, heads, or heads, heads, tail. These are all different scenarios because all of these probabilities for the first scenario, for the second scenario, this tail is 2 over 3. This tail is 3 over 4. So every single scenario is different, and hence we'd have to find these different separately. Okay. So tails, head, head has to be the first one is tails, and the rest 2 are heads. So that is 2 over 3, 1 over 4, and then 1 over 2 plus for the first one head and the second one tail and third one head, that has to be 1 over 3 into 3 over 4 into half. And then for the last one, which is heads, heads, and tails. So the first 2 have to be heads and the last one have to be tails. So that has to be 1 over 3, 1 over 4, and then half again. Okay. So let's see what we can do with this. So 3 for the 12, 24, and then 2 over 24 plus, or just let's just set it as 1 over 12. Then this is 12, 24, 3 over 24, so that is 1 over 8. And then this is, I think, 12, 24, 1 over 24. So if you add all of this, one over 12 plus 1 over 8, you should get 1 over 4. Do we all have the answer of 1 over 4 for 1? Okay, lovely. So we move on to 2 now. So P of 2 is going to be something very similar, where we have to find all the possible combinations of getting 2 tails and 1 heads. So tail, tail, head, or tails, heads, tails, plus heads first and the rest 2 tails. Okay. So similarly, we just find the scenarios now. So, and if you add all of these, you should get 11/24. The last scenario is just P of 3, which means all 3 have to be tails. It's similar to the first one where all 3 were heads. So we only multiply all the values of tails. So that is 2/3 into 3/4 into half. That is 3 4s are 12, 24, 6/24, which is 1/24 all over again. So this should also be 1/24. Okay. So after you're done with this math, you should be checking one thing always, whether all of these add up to 1. We know that the probability of any scenario, all the possible scenarios, should always add up to 1. So if you find that one of your values or if you find that your values don't add up to 1, that means you have messed up in at least one value. Okay, this is not 24, it's 1/4. Yeah, cool. Understood. Yeah, do we all get the same answer? And that's a thumbs ups if you've gotten the same answers. Would any of you like me to repeat what I've done, or any explanations required? Okay, so let's just move on. The second question says, in Milford, 70% of the residents own a bicycle. So this is either 0.7 or 7/10. Something we could use either one of those forms, right? A random sample of 160 residents are selected. Use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. Okay. So there's a concept in the syllabus, which is basically binomial to normal approximation. So the requirements for these are such as one, n has to be greater than or equal to 30. In this case, n is 160, so obviously that passes. Number 2, np has to be greater than 5. So in this case, n is 160 and p is 0.7. So 160 into 0.7 is obviously going to be more than 5. And thirdly, the requirement was nq has to be greater than 5 as well. So again, 160 into 0.3, that is also greater than 5. If I'm not wrong, let me just check. It should be greater than 5, yeah. Since all 3 of these pass, that means it has to be a binomial to normal approximation. Okay. So the way we denote this is for binomial distributions, what we write is x is distributed binomially with n and p. This n is number of things, and this p is probability of success. Similarly, when we have, this is for binomial, when you have normal, what we do is x is distributed normally with np and npq. These are two formulas. The np represents mean and the npq represents the variance. Okay, so this is mean and this is variance. Okay, any questions so far? Do we understand why we have to change this question to normal approximation? Thumbs ups if you understand. Okay, lovely. So when this happens, we also have to change this. Wait, so let's just go one by one. So the question tells us to use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. So the question basically wants us to find the probability that x is more than 120, right? That's basically what the question says. Now, we also know that when we're approximating, this value also has to change. This value either becomes plus 0.5 or negative 0.5. And when does that happen? Let's just see that. So on a number line, think of it this way. A lot of students have a confusion with this, which is I'm going to in details of this. So if this is 120, let's say this is 121, this is 120. Okay. The way we look at this is let's just stand here and we either look towards our right or we look towards our left. So this question says that x has to be greater than 120, which means that we have to look towards our right side. All the values that are more than 120, right? So this part is 120.5 and this part is 121.5. If we take our value to be 120.5, sorry, I made a mistake. This is 119. 119. Yeah. So if we take our value to be 119.5, so what we basically did was 120 plus minus 0.5. And we got the two values, one being 119.5, the other one being 120.5. So this is the two values that we got. So we have either the option of choosing this or the option of choosing this. Now, this entirely depends on the symbol here. This symbol says that the value that we choose has to be greater than 120, which means if we stand here and we look towards this side, that is when we get the value that is higher than 120, right? So it has to be 120.5. If you pick 119.5, this value is in no shape greater than 120. Does that make sense? Similarly, if the question had asked from us, let's say x is less than 120, at that point in time, if we had chosen 120.5, 120.5 is in no shape less than 120. It had to have been 119.5 at that point. So since this question asks from us a value that is greater than 120, we'd have to go with 120.5. I hope that clarifies any doubts. Would any of you like me to repeat that? Okay, so this is probability of x is greater than 120.5. This is the approximation that we used, right? Then we have to use the formula for z, which is basically, do we have the formula in MS-19? Let me just show you. And even if you don't, I'll just write it for you. I don't think we have it. So for z, or let's just convert this for p, z is equals to, so it's x minus mean over the SD. Okay, so we got the mean from NP, remember? This was the mean. So N into P has to be the mean. And in this case, N is 160 and P is 0.7. So we have to write these down. NP is equals to 160 into 0.7 is equals to 112. And then the variance was NPQ. So the SD, so SD is equals to square root of NPQ, which is basically 160 into 0.7 into 0.3. So 160 into 0.7 into 0.3. That gives me root over 33.6. So x minus, x minus mu over sigma. That's the formula. Okay. So in other words, we just write mean, x minus mean over the SD, which is the same thing as writing, in this case, P of Z is greater than 120.5 minus 112 divided by root over 33.6. Can you please ask any questions if you have them? Any questions so far?
For the approximation, like in general, if we have greater than or equal to 120, would it be the same as what we're doing right now?
So when it's greater than equals to 120, as in you're referring to this point, right?
Yes.
At that point in time, you'd have to choose this value. Sorry, wait, let's just think about it for a second. So yeah. So if you take 119.5 at that point, think about it, 119.5, and you take a value of x that is greater than this, do you not cater to 120 as well? Let me just rephrase this. So we still have two options, right? Think about it this way. Think about from this point, okay? So I'm standing here and I can either choose 120.5 or I can choose 119.5, right? The question recurs from me that I have a value of x that is more than and equal to 120. So this equal to is part of it, right? So since I have to cater to that value as well, so if I take 120.5 and let's say I take it to be like this, 120.5, I would just start from this value, 120.5, and go to all the values that are higher than that, right? Am I really catering to this? Sorry, am I really catering to the 120? My x should have also been equals to 120, right? Am I catering to that? Could you please unmute so we could, clarify any doubts that you have?
No, I don't think it does.
Yeah, exactly. So if you're choosing 120.5 and we say that all the values that are greater than equals to 120.5, we are no longer thinking about the 120 that we're also supposed to incorporate, right? Which is why we have to choose this value so that when we choose the values that are higher or equal to 119.5, we are also catering to this value. Does that make sense?
Yes.
Okay, thank you so much.
Thank you.
Yeah. Please let me know if you have any questions. Okay, I'm here for you. So if you finish this, if you put this in the calculator, I think you should have a value of 1.466. So P Z is greater than 1.466. Do you know how to do this from the SD table? Or do you know how to do this in general? When Z is greater than a value, do you know the formula for this? Can any of you show thumbs ups? Or you have any questions for this? So the formula for this is basically 1 minus phi of 1.466, right? So I can plug this into the calculator or I can use the table to find the value of this. And I think I should have 1 minus. If I use my calculator, I'm going to get this. Okay. So my final answer is something along the lines of 0.0713. That is my answer. Of probability being, what is the question again? More than 1 point. Any issues anywhere? Okay. Do we all have the same answer? I hope you're solving with me. Okay, let's just move on. So third question says, I think it's a probability question. A bag contains four blue marbles and 12 red marbles. One marble is selected at random from the bag. If the marble is blue, it is replaced in the bag. But if it is red, it is not replaced. A second marble is now selected at random from the bag. So we basically have two bags. We have one bag. If the marble that we take out is blue, it is replaced in the bag. Do you know what replace means? Replace means we either keep the same thing back, or we take something and we replace whatever is missing from the bag. Okay. And if it is red, it is not replaced. That basically means there were 12 red marbles. We take one out and we see that it's red and we keep it outside. We don't keep anything back in the bag. Okay. So from 16 marbles, it turns to 15 marbles now. That is how it works. Okay. I'll give you guys that's 3 minutes. You guys please try to attempt this question and then you give me the answer in the chat box. Do we have any answers? Okay. Please let me know the answer once you've finished it, okay? Do you have an answer?
I got 49 over 80. Not sure if that's correct.
Perfect. It's the correct answer. Okay, so I think we can start solving then. The question basically tells us that there's blue marbles and red marbles. If we have a blue marble, then it is replaced and kept back in the bag. If it is a red marble, though, however, it is not replaced. So though we don't have to necessarily draw a tree diagram, let's still draw one just so it helps us. So a blue marble here, a red marble here. So for the blue marble, it's 4 over 16. So that's just 1 over 4. And for the red marble, it's 12 over 16. So that is 3 over 4. If it is a blue marble, we just keep it back. So when we go to the second round for blue and for red, it's still just 1 over 4 because it's the exact same thing as the first scenario. And for the second scenario, it's still the exact same scenario because we didn't change anything. Okay. However, if we go down this route, then we pick the first marble and we see that it's red, and then we don't keep it back anymore. So after that, our red marbles become 11 and our blue marbles is still 4, right? So for blue, it becomes 4 over 15 now. And for red, it becomes 11 over 15 now. So since the question says that they have to be the same color, that basically means P of PB plus P of R and R. So that is 1 over 4 into 1 over 4 plus 3 over 4 into 11 over 15 into 11 over 15. This work out, right? Any issues with this? Okay, perfect. So I think you should get 49 over 80 if I'm not wrong. Yeah. So let's go to the next question. Find the probability that the first marble is given blue. Sorry. Find the probability that the first marble is blue given that the second marble is red. So this is a question for conditional probability. And the way we write this is P of A, P. So this is P of A and B together divided by just P of B. So that's the formula. The formula basically says that event A, given that event A has happened, find the probability that event B also happens, right? So in this scenario, this A and B is going to be that first marble is blue. So let's call this B1, given that the second marble is red. So that is R2. Okay. So the first thing that we choose has to be a blue one, and the second one has to be red. So the way we do that is we find the probability of B1 and R2 together divided by probability of getting R in my second attempt. All the ways, right? So this could be one way and this could be the second way. That is the two different possibilities for probability of R2. And probability of B1 and R2 is just this one, right? Any issues with this? A relatively easy question compared to the other conditional probabilities that often come. So let's just solve it real quick and move on to the next question. So this is 3 over 4 divided by 1 over 4 into 3 over 4 plus 3 over 4 into 11 over 15. Do we get the same workouts? Okay, perfect. I think this answer gives me 15 over 59. This is the answer. So, does anyone have any doubts? Or can we move on to the next one? Okay, thank you for your responses. Let's move on to the next one now. So vehicles approaching a certain road junction from Bromley must go either left, right, or straight on. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. The driver of each vehicle chooses the direction independently of all other drivers. So just to picture this is very simple question, as in a very simple scenario. There's three options here. We either go right, we either go left, or we go straight on. For left, the probability is 3 over 10. For right, it's 1 over 4. And for straight, it's 45 over 100. Let's just keep it at that. Okay. The driver of each vehicle chooses the direction independently of all other drivers. That means what one driver chooses has no impact on any other driver. Okay. So it's a very important concept. Statistically, just know this. So find the probability that the next three vehicles approaching this junction from Bromley all go in different directions. So there's multiple ways of approaching this. It's either, let's say, one goes left, one goes right, one goes S. Then this would also be SL, what's it left? RLS. This could also be all of these combinations, right? So please take 2 minutes try to solve this in your own way, and then you give me the answer, and I'll tell you whether it works out. Does anyone have the answer? Okay, let's try. Let's perfect. I think the answer is correct. Let's still solve it for everyone else. So when we start approaching this question, we'll notice something that is very common in a lot of questions, that the values keep on repeating. So let's say this is the first driver, this is the first, this is the second, this is the third, and so let's say the first one goes left, second one goes right, the third one goes straight. So the probability of this happening is, for the left, it's 3 over, or let's just use the values of decimal. And then for right, it's 0.25. And then for straight, it's 0.45. The second scenario, let's just say it's R, L, S. And we'll see that 0.25 into 0.3 into 0.45. What keeps on happening is, regardless of how we shuffle around these values, the corresponding probabilities remain the exact same. So regardless of what the order is, these are going to give the exact same values, right? With that being said, since I have 3 numbers, all the possible combinations for this would be just 3 factorial, which is 6. So if I shuffle around, I'm only going to have 6 unique combinations like these, right? So all I could do is just find one of these answers and multiply that with either 3 factorial or just 6. So this is, I take any one of these and I either multiply with 6 or multiply with 3 factorial. Does anyone have a question with where this comes from? Do we all get this? So the workout is simply 3 factorial into 0.3 into 0.25 into 0.45, and the answer should give me 81 over 400. Okay. The next question says, find the probability that from the vehicles approaching this junction from Bromley today, the first vehicle to go left is before the 9th vehicle. So this, does anyone know which type of question this is from, or like which chapter this is from? It's geometric distribution, right? It's geometric distribution, because this question uses the concept of some event happening for the first time before other events or after some event, right? So the way for determining whether a question is binomial distribution or geometric distribution is, binomial distribution is going to ask you stuff like, let's say we toss a coin 10 times. This is binomial, by the way. So binomial will ask you that we toss a coin 10 times. Toss a coin, let's say 10 times. Find probability of 7 heads and 3 tails. Actually, just 1. Yeah. So this is what binomial asks you. Binomial gives you a scenario and they give you a specific probability to find of a particular event happening. Whereas geometry tells you that we keep on doing something until we get the first success. So in this case, the success was considered for a vehicle to go left. And we consider that that is going to happen before the 9th vehicle. Okay? So this question is basically asking from us. That's basically the difference between binomial and geometric. And this question, since it asks from us about the first time the first time a success occurs, so geometric, so G occurring before the 9th vehicle. This, right? Now, if you recall the geometric distributions formulas, you will remember that this formula does not necessarily exist, does it? And since it does not, what we had to do was we subtract 1 from this, and then we get a formula that actually exists in the syllabus, which is P of X is less than equals to 8. Now, a lot of students struggle in understanding this, and hence I'm going to try my best to explain this. So when we say X is less than 9, we are referring to all the number line values. This is 9, this is 8, this is 7, 6, so on till 0. So when someone says X is less than 9, let's say I'm standing here, and I need the values less than 9. So look towards my left-hand side. It basically means all the values starting from 8 till 0. Because in geometric distribution, my values has to be discrete. It can't be values like 8.2 or 8.5. It has to be either 8 or 9. So when I say less than 9, I'm referring to all the values from 0 till 8. And if I'm referring to X is less than equals to 8, it's also basically standing on 8, counting all the values towards my left, but also including 8, right? So ultimately, X is less than 9 is the same thing as X is less than or equals to 8. And since we know this formula exists in the syllabus, we can use this one, but not this one, because a formula like this does not exist in the syllabus, right? So the 2 formulas that we have in the syllabus for geometric, actually we have a couple of more, but let's see. So X equals to R is Q R minus 1 into P, and whenever we have X is less than equals to R, we have 1 minus Q R, right? So as you can see, we don't have a formula for this. We don't have this. So whenever a question is given like this, you have to convert it into P of X is less than equals to R minus 1, okay? So if you didn't know this before, please write it down. It's a very important thing to know in the syllabus. So we can now use this formula. So that is 1 minus Q to the power 8, okay? Now, if success was 30% for left, that means failure has to be 70%, right? So P is 0.7. That makes Q 0.3. So I get 1 minus 0.3 and sorry, I completely opposite. So P was 30% go left. So that is 0.3 for success. And for failure, that's 0.7. So it has to be the other way around. This is 0.7 to the power 8. 1 minus 0.7 to the power 8. If you plug this in the calculator, I think we get something like 0.942. That is the answer. Okay? Let's still just check. Yeah. Does anyone have any question with number 1 or 2 before we move on to C? Okay. So the third question says, find the probability that from the vehicles approaching this junction from Bromley today, the second vehicle to go left is the 7th vehicle. So this is also a question. This is also a question that comes very often. The way we approach this is we first draw 7 spots. 2, 3, 4, 5, 6, 7. So this is the second vehicle. This is the second vehicle that goes left. Okay, so my first vehicle has to be from one of these. Do you understand this? Okay. Do we know how to find the possibility of one of the vehicles from being the first 6? I think this relates to one of the chapters, right? This is binomial. The concept is of binomial, where they say that n is equals to 6, which is basically out of 6 experiments, what is the probability that I have x equals to 1, right? For anyone still confused, let me just repeat that. So the first thing we do is we draw 7 spots, and the question says the second vehicle to go left is a 7th vehicle. So this is the second vehicle, which means the first vehicle has to be from one of the spots in the first 6 spots. Okay. So the way we do this is we consider this to be 6 different experiments, and we find the probability that one of these from the 6 spots available are the chances of success, right? So one of them will go left from these 6 vehicles. And the way to do that is by using the binomial distribution chapter. And we have a formula for this. Does anyone recall it? It's 6C1 success 0.3 to the power of what we want. So that is 1. And then failure 0.7 to the power of remaining. So 5, right? And I think we get something. Wait, let's just check the value of this. Six C1 into 0.3 into 0.7 to the power of 5. So this is 0.3025. Also, it is very advisable that you take as many significant figures during the workout stage, and then in the answer, you can reduce it down to 3 significant figures or whatever, okay? So this is for the first 6 spots. And then for the 7th spot, I also have 0.3 here, right? Because my second vehicle is also going to go to the left. So this into 0.3, okay? So this I get to be 0.3, 0.09, 0.08. I think this is the answer. Okay. Can we see a round of thumbs ups? Please let me know if you have any questions or you want me to clarify anything, okay?
I actually have a question.
Yes, please.
Why don't we multiply our probability of x equals 1 by the number of spaces there are in those blocks?
Could you please repeat that?
Why don't we multiply the probability of x equals 1 to the number they are like in the boxes with the line?
So you're basically saying, why don't you multiply the probability of 1 with all 6 of these?
Yeah.
Okay.
It may be a
So-
stupid question though.
Okay, no. It's completely normal. Don't worry. So in binomial distribution, what we do is we think of all of these events as different experiments, and we think that how many of these experiments are going to have the desirable outcome that we want. So the reason for choosing binomial distribution for this instead of permutation, combination, or any other method was so that we can consider all 6 of these events as different events, and then we think that from all of the 6, I'm only going to have 1 success. That is the entire concept of binomial, right? This question could also have said that among 6 experiments, what is the probability of getting 2 successes? That is basically how we used to solve binomial maths. So this question says that I have 6 experiments and I have to get only 1 success. So I no longer consider these to be different spots. I don't have to swap them around. I don't have to see all of the arrangements. I only have to find that among 6 different experiments, what is the probability of getting only 1 success? That is exactly how this binomial works. this part looks after the question that you were asking for. The 6C1 basically says among 6 spots, I'm only going to have one of these events. Okay. So only one will have 0.3. All rest of the 5s will have 0.7. Hence, we don't have to worry about the spots anymore. Whenever we are solving for binomial distribution, we don't have to worry about arrangements, or we don't have to worry about swapping around the spots. Cool?
Yes, thank you very much.
Okay. Please keep on telling me if you have any difficulties or you have any questions, okay? I really appreciate it. Thank you. Okay. So this question is for cumulative frequency. Do we know how to solve cumulative frequencies? I think it's the one where students score the most marks because it's as long as you've practiced how to draw graphs, it's very hard to make a mistake in this question. You simply have to wait, let's just look at the question for a second. Okay, so something that a lot of students don't know if they haven't attended classes or they're only starting the syllabus towards the end is how cumulative frequency works. So when I say that for less than 10, I have t equals to 34, that means from 0 till 34, I have 10. When I said t less than 20 is 86, it does not mean 0 to 20 is 86. It does not mean this. It rather means that from 10 till 20, I have, sorry, I actually meant the opposite thing. It means from 0 till 20, I have 86, but it does not mean that from 10 till 20, I have 86. What it means is from till 20, I have 86 minus 34, right? Similarly for this, for 20 till 30, I have 142 minus 86, right? And that's how we finish the whole graph. So once we have all the values, we only need these values for later parts of the question. We generally never need this for drawing the actual graph. So for the graph, we label one of the sides to be t and the other side to be y, or like whatever the question is saying in this one. So it's students. One side is going to be students, the other side is going to be time. So I think it's appropriate if we take this to be the time, and if we take this to be the cumulative frequency for students. And if you plot all of these, so the hardest part in this is just to choose what intervals to take. So the way we decide that is saying to yourself, you have 1 box, 2 box, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could easily fit from 0 to 90 here, right? Similarly, on the upper end, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. Since I have 300 over 16 is going to be something just below 20. So what I'm rather going to do is just use 15 boxes and make it intervals of 20. Does that work? That is one way of doing this. The other way is taking way bigger intervals. So since you can see that this question has big jumps from 34 till 86, till 142, 208, 265, 300. These are very big jumps. So I don't necessarily need to use all of the boxes that way. What I can do is just take turns of 50s, let's say. So I could easily, since I have 15 boxes, let's think, for every 3 boxes, or for every 2 boxes, I could have 50. So if you started here, this is our 50, this is our 100, 150, 200, 250, 300. The question always requires you to use more than half of the graph in both your physics labs, in your chemistry labs, in your S1 as well. Whenever you're given any graph, utilize your space in a way that you use at least half of the graph. Okay, so you can choose any interval that you want as long as it's justifiable and as long as it's appropriate, you can use that. And then you plot the values and you draw a curve accordingly. Okay, it's gonna be something based on the points that you plot. I'm gonna skip on this question because wait, unless you guys want me to solve it, is there anyone who would like me to show this specifically? Can you please raise your hand or you just unmute in case you want me to solve it? I have no issues in solving it. Okay, lovely. So the second part of the question says 120 students take more than k minutes. So it's a very important thing to understand what this means. More than k minutes. Okay, so let's say if this is k, they're referring to this part of the graph. Okay, so 120 students take more than k minutes to travel to college. Use your graph to estimate the value of k. So since we don't have a graph, I'm just going to explain to you how to solve this question. So this question tells me that 120 students take more than k, but I don't have a value of k, right? So there is no way for me to guess the value of k without using what I actually have. So in other words, if more than k is 120, that means till the point of k, I have 180. Does that make sense? So starting from 0 till 180, these people take less than k minutes. And then from k minutes onwards, I have 120 people. So wherever my value of 180 was, if this is 150 and this is 175, my 180 should be exactly here. So let's say my graph was something like this. Whatever my value for this was, this has to be the value of k. Does that make sense? Because the question says that more than k, if this is k, then more than k is all of these parts, and more than k takes up to, yeah, more than k is 120 students. So this is 180, and the students remaining are 120 here, right? So that's the concept here. We have to solve this math in reverse. If they give us 120 is more than k, I have to use the opposite knowledge, which is that less than k is actually 180. And this is the value that I actually have. Cool? Can I say thumbs up if you understand this? Oh, lovely. Let's go to the next question. Calculate estimates of the mean and SD of the times taken to travel to the college by the 300 students. Okay. Do we know how to do this? From a cumulative frequency graph or a cumulative frequency chart, do we know how to solve these maths? Yes? No? Okay. So this is an important question because it involves classes in this shape, as you can see. And remember, I was telling that we need these values. This is when we actually need the values, okay? So let's just find these values real quick. So this is, I think, 52. This one is 56. This is 66. This is 57. And this is 35. Okay. So for mean and SD, we have to use the formulas for mean to be summation of fx divided by summation of f. Sorry, not fx in this way. It's f into x. Fx means functions, yeah. And then the problem with this table is if you have classes from 0 till 10, from 10 till 20, and etc., the problem with this is I don't have a value to multiply it with, right? As in, if I have all the values from 0 till 10, what am I exactly multiplying with? Or all the values from 10 till 20, I don't have something to multiply it with. And I need fx. So I need a value of x that I can use to multiply, right? This is where, whenever I have a model class or whenever I have a class involved in the question, I always have to find the middle values. So there is 10, there's 20 till 30, there's 30 till 40. Okay, let me just directly write all the middle ones, okay? So mid, x. And then we have the f's. So from 0 to 10, I have 5. This is 5, and this was 34. From 10 till 20, I have 15 and 52. 15 and 52. From 20 till 30, basically this, the midpoint has to be 25, and my f value is 56. Then from 35, my f value is 66. from 45, my x value is 57. And from 60 till, sorry, I don't think I have 45. Yeah. The question does not have 45. So from 40 till 60, the difference is actually 20. So the midpoint has to be 50, right? And it's still 57. So 50, 57. And lastly, from 60 till 90, my midpoint has to be 75. And the F value is 35. In case you don't know how to find the midpoint is basically the old value plus the new value divided by 2. So in this case, for example, 60 and 90, what I did was 60 plus 90 over 2. So 60 plus 90, which is 150 over 2, that is 75. Or for example, let's say from 30 to 40, the midpoint was 30 plus 40 over 2, so 70 over 2, that is 35. In case someone doesn't know, okay? So with that being said, now what we have to do is we have to find the fx and we have to add all of those, right? Because the summation of fx. So to find this, we have to first find the fx and then sum those. So 5 into 34, that is going to be something. So for finding the mean directly, I can just add all of these up. So 5 into 34 plus 15 into 52 plus 25 into 56 plus 35 into 66 plus 50 into 57 plus 75 into 35. Does anyone know what we're going to divide this by? What's the summation of f? Yeah, will you answer it?
Would it be 300?
Exactly. I think someone just left. They have another class perhaps. Okay. So this is going to be 300. And then our answer comes out to be, I think, 10135. 10135 over 300, right? So we multiplied all of these and we added those values here. And then we divided them to 300 to find the mean. Cool? Then for the SD formula is a bit messy for anyone seeing it for the first time, but hopefully you're not. So the summation of fx square over summation of f minus the mean square, right? So x square. Any questions? So for finding this, what you have to do is the midpoint that we found out, we have to whole square those and then multiply those again with f, right? So x squared, this is 25. This is, let's just write it this way. And then we can use the calculator. So this is 5 square, this 15 square, 25 square, 35 square, 50 square, and this is 75 square. So now we're going to have a new column, new row, which is fx square. So we take this value and we multiply it with this value for this. Similarly, we take this value, multiply it with this to get this value, right? And then once we have the summation of all of this, we divide this with 300 all over again. So it's going to look something like, let's see. So 34 into 5 square plus 52, 15 square plus 56, 25 square plus 66, 35 square plus 57, 50 square plus 35 into 75 square all over 300 for the first part, and then minus the mean of x whole squared, right? Any issues so far? So if you plug all of those in the calculator, I think we get something like that's a huge value over 300, and then minus we use the previous value that we had, so that is 10135 over 300 whole square. Okay, and once we solve this in the calculator, I think we should get something like 20.4. Then this answer is equal to 3 significant figures. Any questions, anyone? Okay, lovely. Let's move on. So the next question is permutation combination. I think we have one other question after that. Yeah, and then we'll be done. So this question has the word find a different number of ways in which the 10 letters in the word amalgamate can be arranged so that there is an M at the beginning and M at the end and no A's are together. So in this question, we have 10 letters. The first thing you should always do whenever you have a question like this is you list the number of letters and their quantities together, okay? So I can see that I have 4 A's, 1, 2, 3, 4. We just list them. And then we have 2 M. We have, I think, just 1 L here. So 1 L. And then just 1 G. Just 1 T. And I think we have just the E remaining. 1 E. Okay. So it's very important that you understand the questions in these, because these questions will usually require the least workout. It barely has 3 to 4 lines of workouts, but to come to that conclusion, it requires a lot of practice or knowledge for this chapter beforehand. So the question in this one asks from us that there is an M at the beginning and M at the end and no A's are together. So let's just place the M's together, and there's going to be exactly 8 spots, 3, 4, 5, 6, 7, 8, and then M. So we have placed both the M's in the beginning, right? The next thing we do is we have been told that no A's are together. So since there have been 3 criteria set here, one are the M's, one are the 4 A's, and the other is this group of 4 different letters here, right? So we could just sort this together to be 4 factorial. Any issues with this? And since the question tells me that no A's are together, that means the A's have to be in between these or in front of them or basically wrapped around them. Okay, so let me just help you visualize this. So my A's can be either here or here. 3, 4, 5. I think 3, 4, 5, 6. Oh no, I made a mistake here. Yeah. So I have 4 letters here, the L, the G, the T, and the E. And my A's can be placed anywhere here between these spots, right? So my 4 A's have to be placed in these 5 spots. And the way we do that is 5P4. Any issues with that? Could you please raise your hands if any of you have any difficulties on understanding this? Okay, I hope you have understood so far. And lastly, we have to consider that these 4 A's are all identical, right? This means this has to be divided with 4 factorial as well. So if you bring everything together, for the first thing we did was we have to sort these out. So that is 4 factorial into, I have to find all the spaces that I can put my A's. That is 1, 2, 3, 4, 5. That is 5. And then P4 because I had 4 A's. So I have 5 spots and I have to place 4 A's between them. That is 5P4. Divided by 4 factorial, because my A's are all unique. Sorry, my A's are all identical. So in order to sort that, I have to divide by 4 factorial as well. So this and this gets cancelled out, and 5p4 is, I think, 120. So that should be the answer. Do we get the same answer? There can be other methods of solving this as well. There could be methods of, I think, m in the beginning, m at the end, and then all A's are together, and then we subtract that from all the possible methods, right? So there are multiple ways of solving this. As long as you get to this conclusion in a valid mathematical way, it's completely fine. No one's going to stop you. Okay. So next question says, find the different number of different ways in which the 10 letters in the word amalgamate can be arranged with exactly 3 letters between the two ends. Another very common question. So this question requires you to first arrange the letters they're asking you. So there has to be 2 M's, and in between them, there has to be exactly 3 letters. Okay? So with these 3 letters and the 2 M's, we have 5 letters so far. And the question said that it has 10 letters. So there has to be more 5. 1, 2, 3, 4, 5. So fundamentally, what you have to find out is first how to sort these 3. And secondly, all the possible combinations that you can do by moving this M around. Okay? So let's see how many times I can move this M. I can move this once here, second, third, fourth, fifth. Okay? So I can move this M exactly 5 times. And I have 3 spots here. I have 5 spots here. So take 30 seconds, think to yourself how you can solve this. And if you face any difficulties or you'd like me to check your answer, please let me know. After 30 seconds, I'm also going to solve this. Would you like me to check your answer?
I got 560.
560, right? Could you please explain to me your method?
So I first found the number of permutations in the 3 blocks, and I did that by saying A choose 3,
Okay.
and then I multiplied that value by 2 because the M and 3 letters between the 2 M's can be there twice because there's 10 letters and those take up 5.
Why do you multiply it 2 again for the M's?
Because the 3 letters between the 2 M's they not interchange with the other letters. Like, can they
So
not?
do you mean replacing this M with this M, or do you mean replacing it with some other letters?
No, like them as a group, they can be on the other side of the other 5 letters.
Okay. So let me try to explain it to you the way I understand it, and then we can probably come to a middle point, right? Yeah?
Yes.
Okay. So the way I see it, that we have fixed these 2 M's, as a part of a group, right? So we don't have to work with the m's anymore. The m's are fixed as the way as it is, right? And then I have 3 spots here. I have 5 spots here. How many spots do we have in total? 8 spots, right? And since I have no restriction on how these 8 letters can be arranged or how these 8 letters can be sorted, can I not just put 8 factorial for these 8 letters, for all the remaining letters? So we've gotten rid of this m and this m. That is the only other repeat, right? And the second repeat that exists are the a's. So remember, for a's, I have to put 4 factorial here. Any issues so far?
No issue.
Okay, so when I have 8 factorial divided by 4 factorial, what I'm basically doing is arranging all of these 8 spots by taking into consideration the 4 repeats of a's, right? So with that being said, now I have to see how many possible combinations I have like this. So like I counted the last time, I can take this m and I can shift it 5 times. 1, 2, 3, 4, 5. So this m can shift from me 5 times, as in this entire thing, these parts only. They're going to shift each time, right? And as they shift, more letters are going to get added on the left side, right? So since this m can shift 5 times, including this scenario, do I not have 6 situations like this? Do you see it? So
Yeah.
this into 6 is what I think. Okay? So 6 scenarios, because this is the exact same scenario being repeated 6 times as I shift my m 5 times. And then I have this remaining 8 letters, these 3 here and these 5 here. And that makes it 8 factorial divided by 4 factorial. If you are thinking that this m can be replaced as in this m and this m are different, so I have to take this into 2. The thing is, when we're getting rid of, when we're doing divided by 4 factorial, what we're trying to do is get rid of the repetitions. So we are getting rid of these repetitions, all the cases where we consider the a's to be similar. Since they're identical, we get rid of these scenarios, okay? So when you multiply by 2, what you're doing is you're adding more scenarios while we're trying to get rid of the scenarios. We're trying to find the different ways, okay? So all of them have to be unique solutions, and they can't take into consideration the repetitions, which is why we don't have to work with the m's. Does that make sense?
Yes.
Okay, thank
but
you.
I was,
Yeah?
but I times it by 2 because I thought that there were 2 scenarios. So, like in the future, how do I know that there are 6 scenarios or how many scenarios that they're supposed to be?
The 6 scenarios was for this. So you think this to be the reference box, right? And then I have to shift this around to see how many possible times I can shift this. So since this itself is 5 letters, and there's 5 more spots here, right? 5 more. So what I'm basically considering is, this is the first scenario. Let me just erase all of these. The second scenario will look something like this. This is the 1, 2, 3. So if you notice this, I've shifted this only 1 box, right? I've shifted this also 1 box, and then there's 4 boxes remaining here, and one of the boxes popped up on the left-hand side, right? The third scenario would be blank, blank, then M1, 2, 3, M1, 2, 3. Fourth scenario, 1, 2, 3, M1, 2, 3, M1, 2. Do you see all the scenarios that I was talking about? These are all the scenarios that I was mentioning. So this is how I know that there's exactly 6. And how did I know this from the get-go? What I did was, I considered this M just the last M, okay? Not the first, none of this matters. Only this one matters. So I look at this M and I think to myself how many times I can shift this M. So I can shift this once, twice, 3 times, 4 times, 5 times. So the first scenario is just this in itself. The second scenario is when I shift it once. third scenario is when I shift it 2 times. That is exactly how I calculated this to be 6. Make sense?
Yes. Thank
Okay, so 6 into 8 factorial for the 8 boxes divided by 4 factorial for the A repetitions. And that's the solution. Okay. Thank you so much for asking. Let's move on to the next part. So 5 letters are selected from the 10 letters in the word amalgamate. Find the number of different selections in which the 5 letters include at least one M and at least 2 A's. Okay. So again, let's try for 30 seconds, or like let's give it 2 minutes, and you let me know what you get. Do you have an answer?
I'm just calculating everything.
Okay.
I got 134.
124? 34.
134.
Okay. But you made a mistake that is quite common, and it's very important that you understand this. Okay. So I'm going to try my absolute best. Please let me know if you understand this. For permutation and combination, there's exactly 2 types of question in these regards, but that they might ask you. Okay. The first part is different selections. Find the number of different selections in which blah blah blah. Okay. The second part is find the probability. Okay. You will see that oftentimes your answer does not match in the margin just because of the difference between these 2 questions. So the first one, let's approach this one. Okay. In this question, the word is already given. Amalgamate. And they're telling you to find The number of different selections. Okay, at least one M and at least two A's, right? So let's give two categories. One is M, one is A, and let's name it others. Okay. So think of all the possible scenarios. I believe you've already gotten them. So let me just write them. 1, 1, and not 1 actually. They asked us for two A's, right? So 1, 2, and 2. Then there's a scenario for 1, 3, and 1. Then there's 1, 4, 0. Then I have to start with 2, 2, 2, 1. And then there's 2, 3, 0. So I believe what you've done is 3C1 into 4C2 into 4C2. And then you solved it similarly for all of them, right? So that is the probability method. When the question asks from you, find the probability of this happening, that is when you do that. Okay? When they tell you to find the number of different selections, think of it this way, that I'm going to have 5 letters. From that, these are already fixed. This is M, this is A, this is A. I no longer have to worry about this. This is already fixed. Okay? So we only have to take into consideration these two. So there is others 2, which means I think 4C2, right? Yeah, 4C2. Any questions?
No.
Okay, so let me just repeat, just in case you have some difficulties in understanding. Whenever they ask from the selections of this variation of question, you take these to be fixed spots. You don't have to calculate these at all. You only calculate the remaining parts, only when they're asking for the selections, okay? So similarly for other questions, none of these have to be calculated. It's just the rest of the parts. So that is 4C1, 4C0, 4C1, 4C0, right? This is 6, this is 4, this is 1, this is also 4, this is 1. These come out to be 16 ways. So the answer for this question is 16, okay? But this is only when they're asking for the number of different selections. Now let's get to what the answer would have been if the question asked from us the probability. For the probability, it would have been your approach. Now I have to consider all the ways of getting this exact sequence divided by the total number. Okay, so that would have been let's see, 3C1 into 4C2 into 4C2. This is also 3C1, 4C3, 4C1. This is 3C1. This is your method, right?
Yes. But I have a question. Are there not 2 M's only? So wouldn't it be 2 choose 1,
Oh,
etc.?
my bad. Yeah, you're absolutely right. I remember the question wrong. So this is that, then 4C3 into 4C0. So when you've calculated all of these, I think you get 134, right? So probability's formula was that number of desirable outcomes divided by total number of outcomes, right? So if we find total outcomes, that is just simply 10C5, right? Any issues with that? I have 10 letters, I'm going to choose 5 letters from that. So 134 divided by 10C5. This exact question, but instead of asking for the number of different selections, if the question asks us for the probability in which the 5 letters included these, then this should have been the workout. Does that make sense?
Yes. Thank you.
In the scenario of this current question, since the question asks for me just the selections, your method has to be to keep these fixed and not worry about these and only calculate these and add the answers. Okay?
Okay.
I hope that helps you big time. This is something that is only understood by doing a lot of paper. So it's very important that you understand this. I hope
Yes,
this
it
is
did
helpful.
help me.
Okay, thank you so much. Let's move on to the last question, I believe, this paper. Yeah. Okay. So Kestrels are birds whose adult wingspans are normally distributed with mean 74.8 and standard deviation 3.2. A random sample of 120 adult kestrels is selected. Okay, so how many of these 120 adult kestrels would you expect to have wingspan between 72.4 and 76.3? So again, since it's a normal distribution question, we denote these questions by mean and then with standard deviation, right? Equivariance. So X is normally distributed with mean and the variance. So in this question is going to be N. The mean is given to be 74.8 and the variance has to be 3.2 whole square since the SD is 3.2. Okay. So with that being said, a random sample of 120 adult kestrels is selected, and how many of these 120 would you expect to have wingspan between? So this is the range you have to work with, right? 72.4 till 76.3, right? The formula, yet again, is P of X minus mu over sigma, right? So since they've told me that it has to be between these two values, so my Z has to be more than 1 and less than 1. As in more than one of these and less than one of these. So let's just try this once again. So P 72.4 minus is this minus this, right? Over the standard deviation, which is 3.2. And then this has to be less than Z. And then there's another side of this formula, which is going to have, instead of 72.4, it's going to have 76.3 minus 74.8 over 3.2. This. So if you calculate both of these, this is the value that you get. This is minus 0.75. And then this comes out to be, I think, 0.469. Okay. Do we know how to solve this from this point? It's basically saying that from our bell jar, this is the 0.469 mark, and this is the negative 0.75 mark. And we have to find the area or the probability from this point, the shaded region, right? So the best way to solve this is to find from here the entirety of this and then subtract that with this small point, right? And the way to do that is probability of Z less than 0.469, and we subtract the probability of Z less than minus 0.75 from that. So basically this whole thing minus this small thing. That's what you do, right? Are you cool with this so far? So if you plug this into the calculator, I believe you get 0.6804. Or even if you just, let's just check this. Even if you just plug this into the table and you try to look for it from that, you also get the same thing. Let's just check the table real quick. 0.469. Yeah, you get this. And then for this, what we have to do is, since this value does not exist in the table, right? A negative value does not exist here. So we have to flip it. We have to flip this and we have to consider this to be 0.75 and find this part out, right? So the way to do that, if you recall, is 0.75. This is the workout of doing this. So 0.6804 minus, and this comes out to be 0.75. So that is 1 minus 0.77337. And this answer should be 4538. Okay. And the question says that to find this with 120 adults, so I have to multiply this value with 120. This is the probability, and this is the number, and then I get the actual value. So this is 0.4538 into 120. That is 54.456 or 54.5. No, wait. Since it expects me to give the number of birds, it has to be a whole number, right? It has to be 54. Any issues with my approach? Okay, thank you so much. Let's look at the second question now. I hope everything has been cool so far. The masses of adult kestrels are normally distributed with mean mu and standard deviation sigma kg. It's known that 20% of adult kestrels have mass greater than 0.202 kg and 28% have mass less than 0.185 kg. So this is the equation. This is part of simultaneous equation, though it's not part of the syllabus, but they expect you to know this. So you have to find two different equations, and then you have to solve for those equations. You have to equate those, and then find the different variables. Okay. Uh, let's give you guys 2 minutes to start the question before me, and then I'll start solving it. And this is the last question of no, the second last. Okay, so the question tells us that it is known that 20% have mass greater than 0.202. So in notation, it means something like this. X is greater than 0.202, and the probability of that happening is 0.2, basically 20%, right? I hope all of you understand this. And then this put into the Z formula is basically just P. Z is greater than. We know the mu is given as mu, and the sigma standard deviation is given as sigma. So it's basically just this. Sorry, it's Z is greater than 0.202 minus mu over sigma, and this is 0.2, right? Now, the way this works is in the diagram, if visually depicted, this basically just means that if this value, how do I explain? Okay, so this is 20% of the people, and this is the majority, this is the remaining of the parts, right? And for a value of z, I'm going to get this. So more than this is going to be 20%. Okay. So do you know how to find this value from the table? Can any of you find the value for me and you let me know what you get? Do you guys know how to find the z value here? So we go to the MF table. Wait, let me just, yeah. So this is basically the diagram that we had, where this mark up till this is 0.8, and this small part was 0.2. So we have to look for a value that basically gives us 0.8, right? It's as simple as that. So 0.8 we get from this plus this 5. So that is 0.842. Any questions? Can I see thumbs up if that makes sense to you? This is 0.8, this is 0.4, and this is 2. Okay, lovely. So this is the point for z that we have, for which we get 0.8 on the left hand side and 0.2 on the right hand side. So 0.842. Let's remember that. So z is equals to 0.842, right? Any issues so far? So now our equation comes out to be 0.202 minus mu, minus mu over sigma is equals to 0.842, since that's the value of z here, right? And if you have to form an equation, let's form it in terms of mu. So this comes out to be, I think, wait, let's just solve it directly. 0.202 minus mu is equal to 0.842 sigma. And then if we were to replace these, so I bring the u to that side, and this minus equals to mu. So I have one equation here, right? In terms of mu. So now I have to find the second equation. Second part says that 28% have masses less than 0.185 kg. That's basically saying the same thing like this, but the other way around. Now, P, x is less than 0.185, and the probability of that happening is 0.28, right? Let's do the same formula z now. So z less than 0.185 minus mu over sigma equals to 0.28. Exact same logic again. So now we have a diagram where if I look towards my left side, because this is the symbol, if I look towards my left side, I'm going to get 0.28 here, which means I'm going to get 0.72 on the right hand side, right? This is 0.72. So if you flip this graph again, we're going to get a graph like this, where this is the 0.28 mark, and these are all the 0.72. Cool? So now we have to go back to the graph, and we have to see where, we have to see where we can get a value of 0.72. Let's go back to MF19. I don't think there's a shortcut for doing this in the calculator. So I see that I have a 0.7190, and if I add this 10, I get 0.72. So that is 0.583. So 0.583. Let's remember that. Yeah. So let's erase this. Z in this case is 0.583. That means, let's try to get rid of some of these values. So my 0.185 minus mu over sigma is equal to 0.583. I think we can use this part as well. Okay, let's bring this down. This is one equation, and this is the second equation that we have. Okay, so now that I have two different equations, I can just put them as equal and then try to find the values for each, right? Any issues with this? Sorry, this z was negative because this z was initially, remember, this z was on this end. So this z has to be a negative value minus z. So this becomes plus and this is negative. Okay. Are you with me so far? Okay, lovely. So if we just equate them to be as simultaneous equations, I think that is very easy. You can also do it in a calculator. Can you please check if you get sigma to be 17 over 1425, and then the corresponding value of mu should be 0.185 plus 0.583 into 17 over 1425. So it should be 0.1. If you just equate these equations, you're gonna get this, okay? These are the two equations that we have. You just put them as equals and then you solve the equation. Does anyone require any extra explanations? Okay, perfect. So this is mu and this is sigma. Okay. Now the last question says 10 adult castles are selected at random. Find the probability that fewer than 3 have masses greater than. Okay, so this is again, we go back to an old concept where we have a number of different events and we have to see that among that we have a specified number of successes, right? So n is 10 and they're basically asking us for x is less than 3, right? Which chapter is this? Is binomial distribution. So I know that for this part, this is the success. So less than 0.202, this is 20%, remember? 20% of the adults have a mass greater than this. So my success in this case is 0.2. And the way of writing this was if it is less than 2. So less than 3 means I have to take into consideration 0, 1, and 2, all of the scenarios, right? So P of x equals to 1, 2, 3. This has to be, so NC0, so that is n is 10 here, 10C0, 0.2, 0, 0.8, 10, plus 10C1, 0.2, 1, 0.8, 9, plus 10C2, 0.2 to the power 2, and then 0.8 to the power 8. Any issues with this? One other thing that you should always know in this math is that it's very easy for your calculator to stop working if you plug this entire equation at one go. And you're often going to see that your answer does not match with the mark scheme, even though your method is entirely correct. So the ideal way to solve this is you plug in just this part and you're going to calculate, and you get a value, let's say 0.04 something. And then you plug in this part, you get a new value, you write this here. Then you get a third part, you add this here, and then you add all three of these, and then you get an answer. Okay? So it's very important that you know this exam hack, that you don't plug in all three of these values at once. Even though you will make 0 mistakes here, your calculator will make a mistake here because these are very high calculations and it glitches your calculator. Okay? So if you add all of these separately, you should get 0.678, and that is the answer. Okay? Do you have any doubts? Any questions you want me to cover? This is the end of the paper. I really appreciate you sticking to the end. I'm really sorry for all the delays from my end. I tried my absolute best to help with every single question and explain every single without just writing the formulas or without just writing the answers. So I hope this has been helpful. I'm providing a form in the comments. I would really appreciate if you took 2 minutes out of your time to fill up the form and provide us a feedback, because as you might recall that we are not really charging anything at all, and the purpose of this entire workshop was just to provide even if a couple of more new informations for you guys that you did not know before and might help you in the long run. It was just to provide you with that and to help you guys. So it would be really helpful towards us if you could take just 2 minutes and provide us a feedback with the form. Okay. Thank you so much. Thank you for the ones who actively participated. Thank you for everyone else who was here till the very end with so much patience. I really appreciate it, and hopefully see you in future workshops someday again. Best of luck for your exams. Bye bye.
Thank you so much.
Bye.
Thank you so much for staying. Bye bye.